Badass coders, soon-to-be coders, and engineer extraordinaires. Today, let's discuss how to add basic error handling to a simple Python calculator script. We will look at how to handle invalid input from the user, such as an invalid operator, or a non-numeric value for the numbers. We will be using the try and except block and the while loop to handle these cases and ensure that the program can continue running smoothly even when an error occurs. So by the end of this video, you're going to have a better understanding of how to handle exceptions in Python and how to use them to improve the user experience of your programs. So let's get started. Let's get started implementing our error handling in our Python calculator. In the getInput method, I am going to hit return here and add the while true loop. And then I want my input code from the user to be within the scope of this loop. So this while true code creates an infinite loop in the program. And so you might wonder why we would want that. Well, it's because we have several lines of code here and we want conditions to apply to each of them. So we use this while true code line to loop over them consistently until we get what we want, basically. So the code inside the loop continues to execute as long as this condition is true. So in this case, the loop continues to run until a valid input is entered by the user. So what we can do here is we have our operation input. So when the user enters an addition, subtraction, or other arithmetic operator. And what we can do is come down here and add a condition. We can say that if operation is not in this group, whatever this group may be, which we're going to add right now, of plus, minus, what else do we have up there? The basic arithmetic. And the division, then if it's not in there, what do we want to do? So if they enter, say, the caret symbol or the dollar symbol, the money sign, then what do we want to do? We want to say, we want to tell them something. So let's tell them something. We can say invalid operator, and we can say please enter a valid operator. And then we could add in parenthesis inside of our string all the operators that are accepted in our calculator. Okay, so this will keep running until the user enters a valid operator and valid numbers. So when the user enters that valid operator, the loop will exit and the program will proceed with the calculation. Otherwise, it'll prompt the user to enter a valid operator, which is what we just added here. So similarly, if the user enters a valid number, then we are going to add a try and except block that will pass and the function will return the values. Otherwise, it'll prompt the user to enter a valid number. So let's see what happens if we enter something that is not within this array here. So let's run our code, and then down here, what if we add the dollar sign and then hit enter? What will happen? So we can already see that the first phase of our error handling is working. We can see that we have printed to the console invalid operator, and then it gives us a message telling us what operators are accepted within our program. So you might have noticed below that after the invalid operator print statement was printed to the console, that the code still ran to ask for the input for the enter first number. And ultimately what we want to say is, hey, keep asking for this input until we get the valid input. So if we did not get a valid input, meaning we got the incorrect input, keep asking until we get that. So one way that we can do that is right after this condition on the if operation is we can enter a word called continue, a keyword in Python. And this continue keyword will continue to ask for the prior code until it gets what it wants. So if I run this now, you can see that it's going to ask for the operation. If we give it an incorrect operation here, like a $sign and hit enter, it prints the invalid statement, but then it repeats itself and it asks for the same value once again. And it will continue to do this. If I enter a $, for instance, it's going to continue to ask for that information. So you can see another clear advantage of adding this continue statement is we don't have to come up here and run the script manually every time to continue to ask for that input. The continue keyword ensures that this code above will be run repeatedly until the appropriate value is entered. Now, if we move on to the inputs for the numbers, we might think that we could just copy paste these right inside with the print statement for the if operation condition. But the difference is in our if operation condition, we are looking for the operator itself. So that condition does not really apply to the input values, which are numbers. So what do we do here? We can use a try except block. And so I'll just show you what that looks like real quick. We won't tab that in. We will leave it on the same level here as the if operator. And we can say try, and then colon, and then down below this, we will actually tab these numbers in that we get back here from the user. And we will use the except, and then we are going to write value error here, which is a type of error, and we already have that given to us with Python. So in here, we might write a print statement saying invalid input, please enter a valid number. So a very similar message to our operator print statement, okay? So there's a reason that we're splitting this up, and instead of just using this if approach, we're going to use this try block and except here. And so let's look at why. So first of all, the try keyword is used in this try except block. So typically if you're going to use try, then you also want to use this except block. And basically the way that it works is the code within the try block is executed. So if there's an exception raised, then the code in the corresponding except block, which is down here, is executed to handle that exception. And so let's look at a scenario for that. The try keyword encloses these two inputs for the first and second number input by the user. And then this actually converts them to floats. Because remember, our user could enter an integer like 5, and this converts that 5 value to 5.0. And this is done because the float function can raise a value error. So that's just the nature of that float function when we converted that value. So because that particular function can raise a value error exception, and that is the exception, then if the user enters an invalid number, like say a letter or a symbol like we take above, or they enter a letter or a symbol instead of a number, then this value error is raised. So the code with the corresponding except block, which is right here, is executed. And that displays an error message, and it prompts the user to enter a valid number again. So, and this is a way to handle specific exceptions that can occur in a specific piece of code. And it allows the program to continue running instead of crashing or stopping. So that's the value in using this try and except here. So let's go ahead and test it out. Run this. We can enter a valid operator this time, like the plus sign, and then let's try to crash it and get that invalid input. And let's enter the @ sign, for instance. And then let's see what happens. We get a trace back, most recent call last. And then if we scroll down here, we can see value error could not convert the string to a float. And again, this is all because the float conversion function can return an exception or a value error when it doesn't get a valid input that can be converted to a float. And so we're just handling that in the exception. So we're saying in the try, we're saying try this. If it works, great. And then we say except in the situation where certain conditions are not met, say we reject this, okay? So we can see that this is working for input 1. Now let's test input 2. So let's run this again and enter minus this time, subtraction, and we could say 2. And then let's test the second input, and we could just enter the and sign. And you see once again we get an unbound local error, local variable num2 referenced before assignment. So let's go ahead and try this one more time, entering all the correct values, and let's multiply these values. So we could multiply 3 times 2 and we should get 6.0, and we can see that it was converted to decimal. We have one more thing to do to finish up our error handling, and that is to add the break statement in this try block. So we will add this break keyword here, and that's the last thing that we need to do for our error handling. And so this break statement is a way to exit the loop. So because of the way that we've set our error handling up, and we've used a try and except block, we use this break statement to basically say, hey, break out of the loop and move on to the next code, which in this case, it would be to return the operation value that was input, the number value, and the number 2 value. And they are called back down here. Here's the call point. And so those are passed and assigned here as arguments into those variables. So again, this break keyword, it's a way to say break out of the loop and let's move on and execute the next code because we got what we need. So in this case, the user will not repeatedly get those prompts like we saw earlier from that continuous loop. So this was a little bit about error handling in our basic calculator app in Python. So we used the while true loop to loop over our inputs from the user so that we could create a condition to check and make sure we had the valid operator input by the user. And then we say, if we don't have that value, then we use the continue keyword to continue asking that first question of the user until we get the valid input. And then we jump down to the try and except block. And we try or make an effort to get the value we need for our number 1 and number 2 values. And if we don't get those, then the code jumps down to our except block and we have an inherent error, which is a value error for our float function here. And so we use that error here to say that, hey, when this is called, if there's not a valid number to convert to float, then we want to trigger this value error, which is again part of that float function. Then we want to print this statement. If we got everything we want in the try block, then we use the break to say, hey, get out of this loop completely, and then let's continue on with the rest of our code. So that's all for this video. By adding error handling code in the script, it ensures that the program can handle invalid inputs, and we can prevent unexpected errors from occurring. So the script now includes a try except block to catch that any value error that may occur when the user enters an invalid input for the numbers, and then when they're converted to float. The script also includes a while loop to repeatedly prompt the user to enter a valid operator until a valid operator is entered. So these error handling measures make the script a little bit more user-friendly, and it's actually more robust this way. And it will perform as expected even when provided with invalid inputs. So I'll catch you guys next time.